All right, let's ask what x is. And you guys all said 3. I'm like, well, you must have realized it was wrong. All right, s should be 3, right? Keep me on my toes. If I divide 6 by 2, it equals 3. It doesn't equal 6. So x equals 3. I'm halfway done with this problem. That means at the very worst, I can get 2 to 3 out of 4 points. All right, just by redrawing a triangle and writing my s's properly. I need to figure out this missing side because that's the length between this one and that one. So I need to find this s square root of 3 guy. So s square root of 3 is going to equal, if I plug that 3 in, it's going to be 3 square root of 3. So this side right here is 3 square root of 3, which means, what does our a equal in this bottom one? Someone raise your hand and tell me what a equals on my drawing. I know ours is going to be different, but what does my a equal on my drawing? Two people can see it. A is right here. Same drawing as here. What does a equal? Nicholas? Not. Oh, I'm just looking for, how long is this section here? So I just redrew the triangles. Brian?
I have 3 square root of 3.
It's going to be 3 square root of 3.
Yeah, I just read it.
Oh, okay. Okay. Because I legit pulled this triangle off and put it right down there, and I said, whatever side this length is, we're going to call it A is this length right here, so that's the 3 square root of 3. And we got it because these two sides are actually the same length. All right, based upon our drawing. So our A is going to equal 3 square root of 3. Does that make sense? I don't want to lose you in the dust or anything. Yep, so we have A equals 3 square root of 3. Well, I don't need to find 2A, because it doesn't ask for this side. I need to find my Y, which is this length right here. So we're going to say A square root of 3. I want to find that side. Well, I'm just going to plug in what A equals. And so it's going to be 3 square root of 3 times square root of 3, which is just going to equal 3 times 9. Nope. Anybody? Square root of 3 times square root of 3? 3. I was going straight to the answer, which is going to equal 9. So my y is going to equal 9. And I did see, yeah.
I solved it a different way. I solved y just doing the entire page.
Did you get y equals 12? Oh, so you solved the big one and you subtracted 3 from it? Yeah, that's 100% fine. You come up with the same answer, right? So what she's saying is, rather than solving for each individual triangle, she solved for this little triangle. She found out that x equals 3. And then she solved for the big triangle, knowing that this is 6 and it's a 60-30. So she found this whole length was 12, subtracted 3 from it, and got 9. 100% fine. Yep. We basically did the same thing. I mean, obviously. All right, so however you want to do it, that will work. Oh, okay, you just didn't. Yeah, okay.
Oh, okay.
Yeah. It's almost like I think some of these problems are important. Oh. I don't know where important problems show up, but whatever. Okay, so the first problem is something we've already seen. I just want to rehash it because I like box problems. Well, if I have a box like this and I go from corner to corner, the first thing you're going to draw is an extra line. You're going to draw a line right down the middle. That's a two-dimensional line. And I'm going to call that C. All right, and that's going to give me 2 triangles. I just created 2 triangles. Let me highlight them. So one triangle is right on the bottom. It's right there. So I'm going to go ahead and draw that triangle. And we're going to have to note that this length is 5. The width is 5, so this is going to be a 5 and 5 triangle. I'm going to change out of yellow now that we have it drawn because it kind of hurts my eyes. What degree measure is this? It's a box? A square? A rectangle? It's going to be a right triangle, so it's going to be 90 degrees. So that's actually a 90 degree. So that means I can use the Pythagorean theorem to go 5 squared plus 5 squared equals c squared. 5 squared is 25 plus 25 is 50 equals c squared. I take that square root of both sides. What perfect square goes into 25? And
25
what perfect square goes into 50? I said the answer is 25. So 25 goes into it, so we can break that apart into square root of 25 times the square root of 2 equals c, which is just going to be 5. Square root of 2 equals c. So we know that know that this c right here equals 5 square root of 2. So when I do my other drawing, so I'm going to do another, let's put it in red. I'm going to draw my other triangle that I have. I have that guy right there. So we're going to go ahead and draw that guy. Terribly draw it, but still draw it. Right, because the height is 2, it's got to be 2 all the way around. So this is 2 here. And we already know this length, because we said that length was 5 square root of 2. And now I just need to find d. Well, that's a right triangle, so we can use the Pythagorean theorem that says that if I have one side squared plus the other side squared, that's going to equal my hypotenuse squared. Well, 2 squared is 4. And the easiest way to do this squared is just think about it. It's 5 squared and square root of 2 squared. So 5 squared is 25. Square root of 2 squared is 2, so it's going to be 25 times 2 equals d squared. Well, that's going to give me 54 equals d squared. I take that square root of both sides. Now all I have to do is think, okay, 54 is pretty big. There's probably a perfect square that goes into it. Does anyone know the perfect square that goes into it without me giving the answer before we even ask? Yeah, 9 goes into it. How many times does 9 go into it? 6. So we really have square root of 9 times the square root of 6 equals d. Well, that's just 3. Square root of 6 equals d, and that doesn't look like a d at all. There we go. And we're done. That's that whole problem. All right, so that was more of a review. We should have done that in the homework before. We should have seen this before. Should have been nothing new. The next one's a little new. So it says the perimeter of a rhombus is 136, and one of its angles has a measure of 60. So it's got a measure of 60 degrees. Find the lengths of its diagonals. So the first thing I need to do is draw a rhombus. So we're going to go ahead and draw a rhombus. And I'll do the best I can with the skills I got with the snap grid. Come on, good rhombus. That's a pretty good rhombus, if I say so myself. I don't care if I say so myself, because I will. What's important about the sides of a rhombus? Maurice? This is true. We do need that. All sides are also congruent. Both diagonals aren't congruent, because a rhombus can be squeaked out, so this one can be longer than that one. But we're going to have important things. The second thing you said was correct, though, that all the sides are congruent. So that means this side is congruent to that side is congruent to that side is congruent to that side. So if I know all my sides add up to 136, how do I find just one side? How do I find just one side? Jack? Divided by 4. And what's 136 divided by 4?
34.
4, yes. So realistically, we did 136. Maybe I'll put it in black on the over here. 136 divided by 4. That's going to give me my 34. That makes this 34. That makes this 34. That makes this 34. All right. Drawing doesn't have to be correct, but I always like to make it as correct as possible. So one of these angles here, is 60 degrees. Now to help you, the one next to it needs to be supplementary, so it has to add up to 180. So if one angle is 60, how big is the other angle? 120. So would this one be my 60 or would this one be my 60 according to my drawing? This one. It doesn't have to be correct, but it's always nice. It helps in your mind if you do things correctly. So that means that this angle right here is 60 degrees. It means that this one is 120 degrees. That makes this one 120 degrees, and it makes this one 60 degrees. That's all the work I can do on the outside. So now we're going to talk about the diagonals, because eventually I want to get to those guys. So we're going to, do I want to do a dashed line? Possibly. Let's do a dashed purple line. So I have diagonals going across. I have diagonals coming down here. When diagonals of a rhombus collide, what kind of angle do they form? A right triangle. Or it creates a right angle, I should say. So this is actually a right angle. Awesome. So we got a right angle. What do diagonals of a rhombus do to the angles? The diagonals of a rhombus, what does it do to this angle? David? It bisects it. So what is the measure here? 30. So we really have 30 degrees here. 30 degrees here, which means this must be 60 degrees. That makes this 60 degrees. Wait a minute. Don't we know something about 30, 60, 90 degree triangles? All right. Yeah. No. No, I've never seen that before in my life. What is this 30, 60, 90 thing you keep talking about? I don't know. First of all, what's a triangle? That's my first question. Okay, so we have 30, 60, 90 degree triangles. Well, let's take one of those bad boys out. All right, so all I'm going to do is I'm going to pull one of those guys out so we can just work on it all by itself. I wonder if I can just keep... Ooh, I can. All right, I want to extend that a little bit. So we'll do that there. We'll extend that line. Okay, so I pulled that out, and we have a 30 degree, we have a 60 degree, and we have a 90 degree. Well, I'm going to go ahead and label this. Well, the side opposite the 30 degrees, what can I label that? The side opposite the 30 degrees, if I'm using S's. Would that be S squared root of 3? Would that be 8S? Would that be 44S? What do I label the other side? And just, oh yes, S. I was way off. All right, what am I going to label the hypotenuse? 2S. And everyone, we'll keep doing it until everyone says it, what's going to be the other side? One more time. S radical 3. But I know one of these lengths. I know this length is 34, right? That 2S equals 34. So 2S equals 34. That must mean that S equals 17. So this length right here, maybe I'll put it in, I don't know, light blue, is 17. Right? Because S equals 17. What does that make this length? If they bisect each other. 17 as well. So diagonal 1 equals? Diagonal 1 equals? Diagonal 1 equals?
34.
34. Awesome. We just need diagonal 2, which is going to be this guy here. So I need to get my S square root of 3. S square root of 3. Well, I'm just going to take that 17 and plug it in for S. So 17 square root of 3, that makes this S squared is 33. That's going to equal, let's put that in ERPL, 17 square root of 3. So this is 17 square root of 3, 17 square root of 3. If I have two of those bad boys, 17 plus 17 is 24. 34, thank you. At least someone's listening to me. So diagonal 1 is going to equal 17 plus 17, which equals 34. Diagonal 2 is going to equal 17 square root of 3 plus 17 square root of 3, which equals 34 square root of 3. And we have both our diagonals. And you will see this problem in your homework, all right, with different numbers. So you can show me that you can actually do it